Well, hello, we're going to do Unit 7. This whole unit is about proportions and similarity, and the very first topic is ratios, proportions, and solving. The first question is, what is a ratio? A ratio is a comparison of two quantities using division. I'm going to show you this in a moment with the way we write it, but the most important thing you need to realize is a comparison between two numbers. And instead of us using maybe subtraction to find out which one's bigger or smaller, we're going to use division to see how much more one's larger or smaller based on division or multiples of it. Is it twice as big? Is it 3 times as big? Is it 4 times as big? And so forth. We have 3 ways to write a ratio. The first one is putting the word 2 between two numbers, like A to B. So we could write it like this. Instead of using A to B, we could say it's a 1 to 2 ratio. We could have 2 different numbers there. We could say it's a 4 to 5 ratio. Okay? So that's one way to write a ratio, with the word 2 in between the two numbers. We could write it with a colon in between, and it means the same thing as the word 2. So if I wrote 1:2, that would mean it's a 1 to 2 ratio. Okay? So instead of the word 2, we have a colon. Mathematicians don't like to write. I know that there are multiple people in this room that fits into. You don't like to write things down. Mm-hmm. And as a result, we make little abbreviations for things. Okay? The last way to write a ratio is as a fraction. The line of the fraction is like the word 2. A, the first thing would go on the top of the fraction, and the B would go on the bottom of the fraction. So if I said 1 to 2, how could I write that in the second way? 1:2. How could I write it as a fraction? 1/2 or 1/2, okay? So the number that's in front goes on the top of the fraction or in front of the colon, and the number that's in the back goes on the bottom of the fraction or the second one after the colon, okay? Questions so far? All right, a proportion. A proportion is an equation stating that two ratios are equal. All right, I'll let you fill in the blank. There's little blanks there for you to fill in. A proportion is an equation stating that two ratios are equal. I am going to give you an example, and I'm going to suggest that you write this example down so that you'll have a proportion on your paper. Because words, for me, don't explain what a proportion is. This sentence is nice, but it doesn't give me a full picture of what a proportion is. We said it's going to have two ratios that are equal. Those ratios will be written as fractions. And so if you want to replace that word, just put like an arrow and put the word fraction. Okay? That would help. So the ratios that we're going to have will be 2 equal ratios or 2 equal fractions. So if I said 1/2 equals, I'm starting off, this is part of my equation, I could write 2/4. That would be a proportion. You're also going to see some proportions with variables in them. So instead of a 2 at the top there, you might have a variable x. So we're going to learn how to solve those today. Okay? So a proportion is just 2 fractions that are equal to each other. Okay? Oh, yay! Amy's excited.
No, I'm not.
Oh, these things. All right, so here is an example of a proportion with letters A/B equals C/D. That's an example of a proportion with some letters. 2 fractions that are equal. We're going to learn 2 ways to use these. We're going to do something with a cross product, and we're going to learn something about means and extremes. Okay? So the cross product, or let's do, I should have put the means and extremes first in that sentence. We're going to talk about means and extremes first. They're just labels for the pieces of these. A and D are called the extremes. Those are the ones at this diagonal. These are called the extremes. going to change colors. And these ones are called the means. That's the B and the C. Okay. You need to write that down on your paper because you are going to have something on your Formula Madness about means and extremes. And so you'll need to know which ones is which for your Formula Madness, okay? All right.
What exactly is our formula?
I'll explain that in just a little bit. That's a good question. Okay. All right. Now we're going to talk about the cross product. There's a really cool thing that happens with proportions. Most people don't like fractions, and so we can make this fraction turn into something other than a fraction. If I took my means on one side of the equation and the extremes on the other, I've got the red one's A and D on this side, and I multiply them, it will equal the means on the other side, which is the B and C. So if I take this diagonal over here, and I multiply it by that diagonal, they're equal. That's the cross product. That is another part of your Formula Madness right there. So make sure you write that down so we can get those in there. Right. Questions so far? And I have that written in text instead of my handwriting. I took the A and D on the diagonal there. I'm going to do yellow, I don't like that. I took the A and the B, the A and the D. I multiplied them, and they're over here on the left. And then I took the B and the C, and they're on the right. Okay. How many have seen this before? Okay. Sort of, yeah. All right. All right. Let's do some examples. This is on your homework. 7.1, number 1, 1, 4, and 7. 1, 4, and 7. We're going to go back for a little bit, and we're going to review reducing fractions. Okay? Reducing fractions, I've got 6 over 12. How can I reduce 6 over 12? What can I take out of both of them? 6 out of both of them. I'm going to write more than you need to. I'm going to write a divide by 6 on both of them. I'm going to divide 6 by 6 and get 1, and 24 by 6 and get 4. I've seen some. So you have just reduced that. By the way, you also have, if I take this out right here, and I put an equal, 6 over 24, I need everyone to look up here instead of doing the rest of it. This is now a proportion, they're equal. This fraction is the same as that fraction, and it's now a proportion, okay? You will do 2 and 3 by yourselves, and now skip down. Let's look at number 4. These are larger numbers. You might have to reduce a couple times. I don't know what goes in 126 except for 2, maybe 3. How do you know? Did you guys remember the rules for 3s? Deciding if 3 goes into something? No. It's really cool, and it's something that would be really nice for you to go fast, okay? I know that 3 goes into 126. This is how I know. This works for 3s and 9s and no other numbers. If I take the number 1 and 2 and 6 and I add them up, what is 1 plus 2 plus 6?
9.
Does 3 go into 9?
Yes.
If 3 goes into 9, that number, the sum of those, then it goes into that number. It doesn't work for all numbers like that, only 3 and 9. What about 1 and 4 and 4? Does 3 go into that?
Yes.
Yes, because it makes 9. So 3 will go into both of those. We might be able to take something else out, but I know 3 goes into both of those. All right, so it's going to go in 42 times. 3 goes into 126 42 times, doesn't it?
Yeah.
Okay.
Yes.
144, it's going to go in 4 with a remainder of 26. 46, is that correct?
3 out of 144?
Uh-huh.
I got 48.
Yes. Thank you, 48. All right, are we finished? No. Have we reduced this fraction?
No.
42 goes into...
I got 7 over 8.
Yeah, what did you take out of both of them?
I did, after I did the 3, I did 2. And
Yes,
I did
2 again. I do that. Divide by 2. And that will be 21 and 24.
And I did 3.
And then you did 3 after that. That'll be 7 and 8.
Mm-hmm.
Now, the cool thing is since 2 and 3 both go into it, then 6 would have.
Mm-hmm.
So you could have done a 6 right here. So if you're comparing your answers with other people, there are multiple ways to do this. So 9, since 3 and 3 would have gone in, 9 would have gone into both of those also.
Mm-hmm.
And so we could have done 9 and 2. Obviously 18, because 9 and 2 would have also.
We could have done 18.
Yeah, but I don't know my 18's timetable, so I wouldn't have known that 18 goes in there. Okay. All right, number 7 at the bottom of this slide, maybe not on your page. We want to know if I would be allowed to put an equal in there. That's what the instructions state. If each pair of ratios forms a proportion. The question is, are those equal fractions? Okay. And so that, just like we were reducing up here, we divided by 3 on the top up here with number 4. Mm-hmm. I want to know that if I took 20 divided by 8, could I reduce it down to 4 over 2? Or could I multiply something to get by 4 to get 20?
5.
If I multiply that by 5, I will get 20.
But
if I have to multiply the same here. If I multiply that by 5, will I get 8?
no.
No. I should get 10. Is this a proportion?
No.
No. I want to go over that again. I'm going to erase what I just did. What I did is I asked myself, 4 times what gives me 20? And we come up with 5. Are you with me so far? That makes 20. Well, I have to be a proportion, it has to be multiplied the same here. So I have to take the 5 down here. Is 2 times 5 the 8? No, so it is not a proportion. You cannot make it equal. There is another way we could have done it. We could have done this backwards. I could have asked myself, 20 divided by what gives me 4? It would have been 5. Then if I divide 8 by 5, do I get 2? No. So either way works. Okay. You're going to do the other ones. I think there's 2 more like that. We're going to move on to number 11. This is a proportion. It says it is a proportion. It says that it should be equal. And so we're going to do the cross multiplier, cross product to figure it out. Remember we said if we multiplied these 2 and those 2, they should be equal. So we're going to make an equation. 10 times v is 10v. And 3 times 7 is 21. You guys with me so far? I don't want to go too fast.
Subtract 7? Oh, wait, no, divide?
We're going to divide, that's right, we're going to divide by 10. What is 21 divided by 10?
Do you want this in a fraction?
That is a fantastic question. Do I want it as a fraction or a decimal? Let's go back to the if you want to call it rule.
Because that's what my calculator does.
He said
Yes.
fraction because it got some
there
typos.
is a
Do I want it as a fraction or decimal?
21.
She says I want it as a fraction and she is correct. How do I know? How do I know? Because I started with no decimals, so I don't want decimals as my answer. So what you need to do is either figure out how to make your calculator give you a fraction or learn how to make sure you reduce, okay? So,
Okay.
can we take something out of 21 and 10?
No.
The only thing that comes out of 21 is 7 and 3, and 7 and 3 does not come out. So I will let you leave me 21 over 10.
Yeah, I was going to say question. I put that into my calculator, I put in the fraction, and it turned straight back into the answer.
Yes, it
So
turned it back
that's
into
why I
21 over
was
10.
like,
Exactly
yeah.
right. And so let's pause this.
Mine too.
Next one is number 15. We're going to skip a little
Yeah,
bit.
I knew this.
This time, I want you to notice that we have more than just one variable down there. We have we're adding down there. We're still going to use the cross product. 6 times 6 is 36. I am going to write 5a plus
That's
6.
what I did.
You don't have to. You probably could have distributed it in your head, but if you don't want to, I'm going to distribute that now. I distributed it. I'm going to move that 30 to the other side by subtracting. So I'll have 36 minus 30, which will be 6. I'm going to divide by 5. Does 5 go into 6? Can I reduce that any further?
I'm going 6.
I reduced by... did I do that wrong?
How you get 6?
I subtracted this 30 over to here and got 6.
Well, if you put it in your calculator as a fraction, it would literally
Right.
just be the 6/5.
Right.
So do you just, is that your answer then?
Yes, ma'am. Just 6/5. This right here cannot reduce. It'll be 6/5. Some of your calculators might say 1 1/5. I prefer the 6/5. It's just as accurate, less writing, and you'll use the word improper fraction makes it sound like it's naughty, like that improper fraction, and it's really not. There's nothing wrong with improper fractions. It's just, I don't know if they named it that and then realized they're going to use it often later. I don't know, but improper makes it sound like it's naughty or something, but it's not. You can leave it 6/5. All right. Number, it's going to be like 19. Very similar. We're going to do the cross product again. Now we have a variable, I've got a variable on the top and a variable on the bottom.
So literally just do algebra and then solve it the way we just did, right?
That's exactly right. I'm going to multiply those two. Those are the extremes, 4k, and the means. I'll have 3. Can I distribute it right now?
That's what I'm doing.
So 3k plus 12, right?
Mm-hmm.
I've got k on both sides this time instead of the
Minus
numbers on both sides.
It's just 12, right?
Yeah.
Yes, so I'm going to just bring the 3k by subtracting, and I'll have k equals 12.
Wait, so the answer's, yeah.
Got it? All right. Questions? We're going to jump now.
What happens when you don't get a fraction? Is that fine?
Yes, that's fine. Just like we had over here. K equals 12 was not a fraction. It's just so okay.
I
Right.
really want to say I'm loving this lesson right now, but I'm afraid I'm going to jinx it.
Now I have, it's a little bit, we're getting more complicated as we go along. I don't have just one variable on both of them. Now I am adding and subtracting to that variable. It's not too bad. Same stuff we've been doing. So I'm going to multiply the extremes, 5n minus 5. Are you with me so far? And multiply the extremes, 3n plus what?
15.
Very
Question.
good.
Does it matter which order you set it up in? Like if you switch the two?
Oh, yeah, not at all. If I would have put this over, that whole side over there and that whole side over there, it would have been so okay.
Okay.
Good question, Amy. Good question. All right. I'm going to add that 5 to the other side to make it 20. And subtract the 3n over there and make it 2n.
10.
Yes, that's what I got.
She did it so quickly.
But I got you.
Brilliant. Good job. Good job. Questions? Yes, please do. That's a good question. We're going to move on to number 27. It's a word problem. We're going to read it, set up an equation, and solve it. It'll be like the one next to it, so that you'll be able to do that one when you get there, okay?
What?
All right, number 27.
Page 2.
All right. Find the measure of each angle if the ratio of the measures of two complementary angles is 4/5. There's some vocabulary in here.
Yeah.
We have ratio is one of the vocabulary we just learned today, but we have complementary. What does complementary mean?
They both add up to 90.
90 or 180? Which is it?
90.
That's correct. What would have been the 180?
Supplementary.
Supplementary. Okay, I'm going over that because you'll need that.
We'll need that
All right.
next
So we have. So that means it adds up to 90. I'm going to just write a little note to myself, and I think you should do the same. Adds to 90 degrees. Okay. Maybe even put that next to the complementary there. Okay. What adds up to 90?
Each angle?
Each angle, that's right. Each of the angles, and there's 2 of them, and it says that they are in the ratio of 4 to 5. That means that I have 4 times something, that's x, for one of them, and 5 times that same x for the other one. Because it's in a ratio of 4 to 5, but it could be, instead of 4 over 5, it could be 8 over 10. We could have 8 be one of them and 10 be the other one. We know that the fraction reduces to 4 over 5. So it's 4 times something, and it's 5 times something, and those are complementary. What does that mean to be complementary again? They equal when we add them, right? They add up to 90 degrees.
Tim?
Yes. Fast. Man, speedy, man. Okay, so 4x plus 5x
40 times
is...
10 is... I mean, 10 times 4 is 40.
Yes. So I'm going to add these 2 together, and that's going to be 9x equals 90. We're not done, though, when we find x equal 10. Did it ask us to find... what did it ask us to find? The measures of the 2 angles. This is not the measure of the 2 angles.
They're different 10 degrees, aren't they?
They're remember I told you that their ratio was 4 over 5, but the 4 over 5 was their ratio. We need to know how much each of those were multiplied by, and we found that it's multiplied by 10.
So it
40
means
and 50.
40 and 50. So what I'm doing in my head is I'm plugging in that 10 in for the x over here and over here. So the answer is 40 and 50. Now, do those two are those 2 adding up?
Write it 40 over 50?
No, because they don't want the ratio of them. They want the measures of each of them.
Oh, so it's
Okay, they want the measures of those angles. And they told you that the angles have a ratio of 4 to 5, but they don't want the ratio. They want what those measures are. Okay?
Okay.
All right. All right. You have learned about proportions and ratios. You've learned how to simplify them or to reduce the fractions or reducing the ratios. You've learned how to solve them using the cross product, okay? All right, and you did some word problems. I'm going to sit down real quick now. I want you to do me a favor and just a quick minute here.